Hi, Dr. Wang here. I'm just going to do a short lecture on the difference between prokaryotes and eukaryotes, as well as the features in the eukaryotic gene. So in prokaryotes, a couple of genes are normally arranged together as an operon. So when the operon is transcribed, I'm going to use a red line to indicate the region of the gene that's transcribed. So basically, it's going to generate a messenger RNA molecule that includes the first gene, the second gene, and etc. From the same operon. So this is a fairly long messenger RNA molecule, and it's called the polycistronic messenger RNA. So during translation, what's going to happen is that this is going to get translated. Basically, translation starts right here. So here, this is the translation product from the first gene, and then here, the second gene gets translated. So this is going to produce polypeptide originating from different genes within the same operon. In eukaryotes, the story is a little different. So the transcriptional unit is a single gene instead of multiple genes for prokaryotes. So only a single gene gets transcribed at a time. So here transcription starts here and ends here. So here I'm going to switch to my red pen to indicate the region of the gene that's transcribed. So this is called the pre-messenger RNA, and after pre-messenger RNA is formed through RNA processing, the intron region will be removed. So here I'm going to use a blue pen to indicate the region of the messenger RNA that's removed. So basically for this particular gene, this region, this region are the introns that will be removed through RNA processing. So the result of that is a mature messenger RNA, right? So once you remove all the intron sequence, put in a 5' cap and 3' poly A tail, we have this mature messenger RNA. So if we look at the mature messenger RNA, we can see that it's made of regions that are translated. So here, this is the region that's translated. I'm going to switch to a green pen to indicate that the region that's translated is basically here. So translation starts right here. Right, it's going to skip the intron sequence because the intron sequence is already removed through RNA processing, and then here, this is the region of the gene that's actually translated. So this is called the CDS. CDS stands for coding sequence, or the sequence that actually codes for protein and is translated. So translation starts right here and then stops right here. All right, so now we have basically annotated most of the sequences in this gene, so we can see that what's left is, I'm going to switch to a different pen now. I'm going to use purple pen to highlight this region. Right? So we haven't talked about this region yet. So from here to here, and then from here to here. So basically, this is the 5' UTR right here. All right, so 5' UTR is a region that's transcribed. You can see that it's part of the pre-messenger RNA. And it survived processing, ended up in the mature messenger RNA, but it's not translated. This is where translation starts. So untranslated region. If it's in the 5' end of the gene, it's called 5' UTR. And if it's in the 3' end of the gene, it's called 3' UTR. So I'm going to come back here and then highlight this region. So this is 3' UTR. All right, so here we basically have annotated all the features within the gene, right? So right here, so this black region is, or the green region is the CDS. So what's left is what's in front of the transcription initiation site. And then here, this is a region that's important for the regulation of transcription. So I'm going to pick up a different color. Um, maybe, okay, so here. So this is the promoter region. So we can see that the promoter region itself is not transcribed. Transcription occurs here. So we can think of this as a landing pad for RNA polymerase. So the RNA polymerase lands here, and it's going to start transcription from this point. And then similarly, we can think of 5' UTR as a landing pad for the ribosome. So the ribosome is going to land right here and then start translation starting from this point. So both 5' UTR and 3' UTR actually affects translation efficiency. And similarly, the promoter region affects transcription efficiency.